This is part 2 of the narrated lecture, chapter 18. So we're going to look at the structures of those proteins. So primary structure is the sequence of amino acids. You need to be able to define what is the primary protein structure, explain how they are represented, and also give an example. Primary structure of protein is the result of the sequence, the lining up of those amino acids in a specific order. Very important to the proper function, and the change of only one amino acid can actually have really drastic consequences on the protein's biological properties and the physiology. Some example right there. Two hormones secreted by the pituitary glands. They are different by only two amino acids in the order you see here. ILE, isoleucine, and LEU, leucine, that can be switched, and you have phenylalanine and arginine. One makes the oxytocin, the other one makes vasopressin with very different properties. Then we're looking at here the spatial arrangement of the polypeptide backbones of protein. That's what is the secondary protein structure. So there are two types. There is the alpha helix and the beta pleated sheet or beta sheet. What's going to happen there is hydrogen bonding between the backbone atoms that are going to hold the polypeptide chain in different places. Those are examples right here showing the hydrogen bonds between the backbone segments. So you either get a secondary protein structure, alpha pleated sheet, and another one will be an alpha helix. Example right here, this is the alpha helix, so it just coils up. This is an example of the beta pleated sheet or beta sheet. It's going to be where you have kind of a pleated sheet that can pack up and forming a flat sheet-like structure. So we can classify also those proteins in different way, but the most two important one are either it's a fibrous protein or a globular protein. Their function are made possible by their distinctive structures. Here, fibrous protein, tough, insoluble protein with protein chain from fibers or sheets, and globular protein, they are water-soluble protein, and they can fold in a compact shape with hydrophilic. Hydrophilic means they like the water groups on the outside. Those are examples. Spider web is made from fibrous protein, and then the proteins that you have in eggs, milk, and cheese, those are examples of globular protein. So when we're looking, this is kind of a summary of secondary protein structure. You look at here on the left is pleated sheet structure. You see the hydrophobic interaction that are just in that pocket. Salt bridges exist as well, hydrophobic interaction, disulfide bonds, hydrogen bonds between side chain. And I really want you to just review the different type of bonding that can exist, making a difference between a pleated sheet or, on the far right, a helical structure. Those are just some examples: collagen, elastin, myosin, fibrin, or those are fibrous protein, insoluble, or the soluble ones such as insulin, hemoglobin, albumins. Looking then at the tertiary protein structure, well, this is the way in which the entire protein chain is coiled and folded even further to its specific three-dimensional shape. So be able to identify the four specific forces that are responsible for those tertiary structure, and also be able to distinguish between simple or conjugated protein. I'll let you read that part. So what we have here, where you start with combination of alpha helix, beta pleated sheet, and they are looping, connecting to each other, and you also have disulfide bonds. So those are just showing you here intrachain disulfide bond on the top, interchain disulfide bond, so there's two chains, top and bottom, that can link them, and those are going to make more coiling and more compact structure. So when we're looking at this, kind of a summary, you start with the alpha helix, the beta sheet, you have some connecting loops, you have some disulfur bonds, all of those are going to make just more coiling. And when you look at this, just some example of conjugated proteins, glycoprotein, lipoproteins, phosphoprotein, hemoprotein, nucleoprotein such as RNA. I'll let you read that part.